So welcome to the next session. In this session we are going to discuss about the measurement of the resistance. So for the measurement of a resistance are classified into three major groups based on the numerical range of the values as under. So here where this classification is done, we are saying that this classification is done based on the numerical values. So one is the low resistance, medium resistance, and high resistance. So low resistance is nothing but it is in the order of 0 to 1 ohm, and a medium 1 to 100 kilo ohm, and a high it is greater than 100 kilo ohms. So according to this resistance can be measured by various ways depending upon the range of the values as under. For a low resistance there are different methods for a measurement of this resistance. The first method is the AV method. Second one is Kelvin double bridge method. And third one is the Dr. Ohm method. Dr. Ohm method. And for a medium resistance, we are having an AV method, Wheatstone bridge method, and substitution method. And for an high resistance, we are having an AV method. Second one is the Megger. Third one is the loss of discharge. Another one is substitution method is also there. Substitution method is also there. So these are the different methods for a measurement of an resistance. Now let us see a low resistance method. So first let us see a measurement of low resistance. So here we are using an Kelvin double bridge method, and the diagram for this method is, this is the diagram. Let us consider the points. This one A point, this is the B point, this is the point C, this is the point D, this is the point M, and this is the point N. Let us have, this is small r, capital R, small p, small q, capital P, capital Q, and here it is the source, DC source S, and current I is flowing in this direction. Now this G is the galvanometer. Now this Kelvin double bridge is one of the best devices available for the precise measurement of an low resistance. It is the modification of an Wheatstone bridge, which the errors due to the contact resistance and lead resistance are eliminated. And this bridge is named double bridge because it contains an second set of the ratio arms. An interesting variation of the Wheatstone bridge is the Kelvin double bridge used for the measurement low resistance, typically the range of an 1/10th of an ohm. And coming to this theory operation, let's consider the bridge as per this circuit diagram. And here R represents the, here small r represents the resistance of the lead that connects the unknown resistance R to a standard resistance S. So this is an unknown resistance R and this is the standard resistance S. And two galvanometer connections indicated by the dotted lines are possible, and the connection may be either to point M or to point N. Point M or to point N. So this is the point N. When the galvanometer is connected to the point M, the resistance R of the connecting leads is added to a standard resistance S, resulting in indicating of too low an indication of the unknown resistance R. When the connection made to the point of the resistance R is added to the unknown resistance, resulting in indication of too high a value of for R. Suppose instead of using point M, which gives a low result of, or N, which makes an result high, we make the galvanometer connection to another intermediate point D. It's the point D. As shown in this diagram, if at point D the resistance R is divided into two parts, let us consider that R1 and R2, such that R1 by R2 is equal to P by Q. P by Q. Now, for a Kelvin double bridge incorporates the idea of a second set of n ratio arms, hence the name double bridge and the use of 4 terminal resistance of the low resistance arms. Though the first arm is an R1 by R2, and the second arm is an A by B. So A by B is equal to, at an balanced condition, A by B is equal to R1 by R2. So it is nothing but it is the voltage at the terminals 4, 5 is equal to the voltage at the terminals 5, 1, 3. And the voltage at the terminals between 4, 5 is given as ER5 is equal to R2 into E divided by R1 plus R2. Now consider the path here. Consider the path 5, 1, 2, 6. So here I am not given any numerical numbers. So here numerical numbers as consider as, so this is the 1, this is the 2, this is the 3, this is the 4, this is the 5, and this is the 6. Now the E45 voltage across the 4, 5 terminals is R2 into E divided by R1 plus R2. And now consider the path. Consider the path 5, 1, 2, 6 back to 5. So E is equal to I into R3 plus, it may be R in parallel with A plus B plus RS, RR plus RS. And now let us consider the resistance between these two terminals is Ry, or otherwise we may be connected another it is remodified into another circuit like this. Let us consider this circuit. So the voltage is applied across these two terminals. Let us consider now, this is the unknown resistance Rx, R3, R1, R2, and let us consider this is small a and this is small b resistance, and the galvanometer is connected between these two terminals. And the resistance across these two are equivalent resistance is Ry. Let us consider this is A, this is B, and they consider the points as 1, 2, 3, 4, 5, and 6. And at the balance conditions, we are saying that the first R1 by R2 and the second combination is A by B. And at the balance, the voltage across the 4, 5 terminals is equal to voltage across the 5, 1, 2. So nothing but A by B is equal to, according to this one, A by B is equal to R1 by R2. And the voltage across the 4, 5 terminals is equal to R2 into E divided by R1 plus R2. And now consider the path 5, 1, 2, 6, 5. the voltage is equal to I into R3 plus Ry in parallel with A plus B into Rx. So again this is remodified as R3 plus Rx into Rx plus A plus B into Ry divided by A plus B plus Ry. Now substitute this value, E value, in an previous equation. Now substitute, let us consider the equation numbers also, then it is very easy. So this is first one, this is second one, this is third one, and this is fourth one. Now substitute equation 4 in equation 2. Then it is modified as the voltage across the terminal 4, 5 is R2 divided by R1 plus R2 into I into R3 plus Rx plus A plus B into Ry divided by A plus B plus Ry. So this is one expression. Let us consider 5. And the voltage across the terminals V12 is given as I into Ry into A plus B divided by Ry plus A plus B. Similarly, voltage across the terminals Y13 is given by B plus A plus B into V12. Let us consider this is 6 and this is the 7th equation. Now this can be modified as B by A plus B into I into Ry to A plus B divided by Ry plus A plus B. And now the equation E45 is equal to, we are saying that the voltage across the 513. Now the voltage across the 513 is given as I into R3. If we solve this equation, we will get like this: B into Ry into A plus B divided by Ry plus A plus B. And we know that E45 is equal to E513. So this is the expression for the 513. This is the expression for the 513. And already E45 equation is written here. So from this both the equations we can calculate the unknown resistance. So if we solve that equation, we are getting that unknown equation. Finally Rx is equal to R1 R3 by R2. This is the final expression for finding the unknown resistance. This is about the Kelvin's double bridge, how we can find out the unknown resistance with the help of an Kelvin double bridge. Thank you.